Okay, so have you ever felt like your brain's just completely overloaded, like you're trying to make sense of something really complicated?
Yeah, it's like wading through mud, right?
Exactly. You're definitely not alone if you feel that way. That's kind of the whole point of these deep dives, to give you the key takeaways without all the fluff. We basically sift through a ton of research and figure out what's actually important.
Yeah, consider it your shortcut to really understanding something
Hmm.
without having to spend hours poring over all those dense articles and studies. We do the heavy lifting for you.
Right. And today we're going deep into the world of concept maps and knowledge maps. So basically, at their core, they're like diagrams with connected ideas. So think bubbles, connected by lines. The bubbles hold the concepts, and the lines show how they're all related to each other.
That's a great way to put it.
Yep.
The source actually had this really neat example. Ocean acidification slows the growth of coral reefs.
Hmm.
It shows how you can link those ideas together visually.
Perfect example. Now, for this deep dive, you gave us this really interesting research to work with, a meta-analysis actually, from the Educational Psychology Review back in 2018. It's called Studying and Constructing Concept Maps, a meta-analysis. But what's really impressive about this study is just how massive it is.
Oh, absolutely. Combined data from 142 separate studies with over 11,000 participants in total. I mean, just talk about a comprehensive analysis, right?
Yeah, that's a lot of data.
Yeah.
So our mission today is pretty straightforward. We want to pull out the most important insights from this huge study and really focus on how using these concept maps and knowledge maps can actually make you a better learner.
Exactly. Make it practical for everyone listening.
Okay, so first things first. What was the big takeaway? What did they actually find?
Well, the overall conclusion was that learning with concept and knowledge maps does have a positive effect on learning,
Yeah.
like a reliably positive effect.
Yeah.
They calculated something called an effect size, which was 0.58. It is also statistically significant.
Statistically significant. Yeah.
Meaning, it means it's very unlikely to be just a random fluke. And considering the sheer number and variety of studies they included, it suggests there's a real advantage to using these tools. Basically, it shows a noticeable and dependable improvement in how well people learn.
So right off the bat, we know it's not just some tiny, insignificant effect. But you mentioned something earlier, heterogeneity.
Ah, yes, good catch. While the overall effect was definitely positive, they did find that the results weren't exactly the same across all the studies, meaning there were certain things that seemed to influence how well the maps worked in different situations. And that's why they decided to dig a bit deeper.
Okay, and one of the first things they looked at was whether it's better to make your own concept maps or to just study ones that someone else has already made. What did they find there?
That's where things start to get really interesting.
Yeah.
The meta-analysis pretty clearly showed that creating the maps yourself was linked to bigger improvements in learning. They found an effect size of 0.72 for creating them
Versus.
versus 0.43 for just studying them.
Okay, so both had a positive impact, but actively making the map yourself seems to be the way to go.
Exactly. The key takeaway here is that while concept maps are helpful in general, you get the most benefit if you're the one actually building them.
That kind of makes sense intuitively, right? When you're actively creating something, you're way more engaged with it than if you're just passively looking at something that already exists.
Absolutely.
But the study also goes into the reasons behind that, right? Why that might be the case.
It does. The researchers connect this back to the idea of meaningful learning. When you're building a concept map, you're forced to think about the information more deeply. You're asking yourself questions, summarizing the main points, and figuring out how all the different concepts are related and how to actually represent them visually. This active processing helps you understand and remember the material much better.
It's not just about absorbing facts, you're really wrestling with the material. But even when you're just studying a pre-made map, the source mentions that there's still some cognitive work happening. They talked about a noun-verb-noun structure. What's that all about?
Right. So even if you're not building the map from scratch, those connections, those propositions can still get your brain working.
Those noun-verb-noun links.
Exactly. Like the example we talked about earlier, elk calf runs from bear. It makes you think more deeply about the relationship between the concepts. Why does the elk calf run from the bear? You're connecting it back to what you already know and trying to make sense of it. And even this level of active engagement just from studying a pre-made map is more beneficial than just trying to memorize isolated facts.
So we're seeing that using concept maps, whether you're creating or studying them, has benefits over just reading plain text. But how do they compare to other active learning methods, like making lists or creating outlines?
Good question. The meta-analysis actually looked at that specifically. They compared learning with concept maps to a few different alternatives. And what they found was that concept maps were way more effective than just relying on discussions or lectures,
Mm.
like significantly more effective. The effect size was 1.05 for that comparison.
Wow.
They were also moderately more effective than studying or creating lists, which had an effect size of 0.43, and outlines, with an effect size of 0.48. And even when compared to just studying or writing text, concept maps still had a statistically significant advantage, although the effects were smaller there, 0.39 for constructing text and 0.29 for just studying text.
So it's not just a slight improvement. In some cases, it's a pretty big difference. But you mentioned a word of caution earlier when interpreting these numbers.
Yes, it's important to remember that within those general categories like discussion or studying text, there was quite a bit of variation between the individual studies. The type of discussion, the specific text being studied, those things could all influence the findings. So while the overall trends are pretty clear, the exact amount of the difference might depend on the particular situation.
That's a good point. We shouldn't take any single number as an absolute rule. Now, a lot of people probably associate concept maps with more technical or scientific subjects. Was there any difference in how effective they were for STEM versus non-STEM fields?
That's what we thought too. The researchers even hypothesized that STEM fields, with all their complex interconnections, would benefit more from concept maps. But surprisingly, their analysis didn't find a big difference between STEM and non-STEM areas. The effect sizes were very similar, 0.60 for STEM and 0.51 for non-STEM.
Really? That is surprising. I would thought those visuals would be super helpful for understanding complex scientific concepts.
It seems like no matter what you're studying, concept maps can be a valuable tool.
So it seems that no matter what subject you're learning, concept maps can be really useful. But what about the different kinds of concept maps? You have your static ones, but there are also animated and interactive versions. Do any of those stand out as more effective?
That's where things get a bit unexpected again. The meta-analysis looked at static maps, the kind you typically draw, but also animated maps where things appear in a sequence and interactive maps where you can actually manipulate the map yourself.
Yeah, I would have guessed those more dynamic maps would be more engaging and maybe easier to follow.
Right. But contrary to what some learning theories might suggest, they didn't actually find any significant differences in effectiveness between the different types.
Oh, wow. So even though animation or interactivity could potentially make it easier to process complex information, it didn't seem to make a big difference in terms of how much people learned.
Exactly. However, there is a caveat here. The vast majority of studies included in the meta-analysis use static concept maps. There were far fewer studies that used animated or interactive ones.
Ah, so the sample size for those other types was smaller.
Yes, and that's important to remember. It means while the current evidence doesn't point to a big difference, it's entirely possible that with more research on those dynamic maps, we might see a clearer picture emerge, especially for the animated maps. The results were more spread out, so there's definitely more to explore there. The initial idea that dynamic maps would be more effective wasn't really supported by this big analysis, but further investigation is definitely needed.
More research is always good. Okay, so the act of creating seems to be key. The subject matter doesn't seem to matter as much. And the type of map, well, static ones definitely work. And we need more data on the others. What about the amount of time spent working with concept maps? Does that matter?
That's a great question. And the meta-analysis actually found that the duration of concept map use did have a significant impact on how well people learned. And get this, longer engagement over 4 weeks was linked to the biggest improvements. They saw a large effect size of 0.72 there. And this is a really important takeaway. It's not about a quick fix. The longer you actually use concept mapping in your learning, the more effective it seems to become. And that actually goes against this earlier idea of a novelty effect, where the benefits might decrease as the technique becomes less new and exciting.
So the longer you use concept maps, the better the results. But even shorter periods of use still showed some benefit.
Absolutely. Even using them for less than a week had a moderate effect size, 0.36. And using them for 1 to 4 weeks had a larger effect, 0.68. So you definitely see benefits even with short-term use. But the longer you incorporate them into your routine, the bigger the gains seem to be.
And did they break that down further, like based on whether someone was creating a map or just studying one?
Yeah, they did. For map construction, they found that using them for longer durations, both 1 and 4 weeks and more than 4 weeks, led to larger effect sizes than just using them for less than a week. This really backs up the idea that the more you actively build those maps over time, the more it helps you learn. But for map studying, the findings were a bit different. They didn't see a significant difference based on how long people studied the maps. However, the few studies that did look at studying maps for more than 4 weeks found a pretty high effect size, 0.70. So while that needs more research with a larger sample size, it suggests that even long-term passive engagement with a good concept map could be really beneficial.
It's a reminder that sample size can make a big difference in research. Okay, switching gears a bit, how about different stages of education? Does the effectiveness of concept maps change depending on the learner's grade level?
That's another really interesting question. And the findings had some nuance to them. So for constructing concept maps, they didn't find a difference in effectiveness across different age groups. They saw positive effects from moderate to large, for intermediate, secondary, and post-secondary students. So building these maps seems to be helpful no matter what stage of education you're in.
That's great to hear. It means concept maps can be used effectively across the board. But you said there were some nuances, so for studying maps, it was a bit different.
Yeah, for studying maps, they did find some differences based on grade level. The biggest effects were actually for secondary and intermediate students, with effect sizes of 1.24 and 0.82 respectively. Pretty big, right? And while post-secondary learners still benefited, the effect was smaller, 0.32. The researchers think this might be because the visual layout of concept maps could be especially helpful for younger learners. It clearly shows the connections between ideas without them having to dig through a bunch of text. That visual format just makes the relationships more obvious and understandable.
It makes sense that younger learners might find that visual structure more helpful. Now, we've talked a lot about individuals using concept maps, but what about when you bring other people into the mix? Does collaboration make a difference?
Interestingly, the meta-analysis found that working together didn't really change how effective concept maps were. It didn't matter if students worked in groups, alone, or a mix of both. The benefits of using concept maps remained pretty consistent.
Huh. I would thought that brainstorming together when creating a map or discussing a pre-made one as a group would lead to a deeper understanding.
It makes sense, right? But in this analysis, collaboration didn't seem to add much to the impact of concept mapping. One possible explanation the researchers suggested is that the core cognitive processes involved in using concept maps effectively, the self-questioning, the organizing of information, are pretty similar to the strategies we use in collaborative learning. So maybe the added benefit of actually interacting with others is less pronounced because those processes are already being tapped into.
That's a really interesting point. So collaboration is generally a good thing, but it didn't seem to make a big difference specifically for concept mapping. Okay, now for a really surprising finding. The location where the study was conducted. Does that have any influence on how well concept maps work? It's not something I would have immediately thought of.
I know, right? That was definitely one of the more unexpected results. The meta-analysis actually found significant differences based on the geographic region where the study was done. And this was true for both constructing and studying concept maps. For instance, creating concept maps in Asia and Europe showed particularly large effect sizes, and studying maps also had regional variations. It's fascinating that even where a study takes place can impact the results.
It is fascinating, but do the researchers have any explanations for these differences?
They admit it's hard to say for sure based on this analysis alone, but they did throw out some possible factors. Maybe it has something to do with the common teaching methods in different regions, or even how different languages are structured. They really highlighted the need for more research to understand these regional differences, like could it be cultural, how information is taught, or how people learn in different parts of the world? Or maybe it's related to how different languages express relationships between ideas. It's really intriguing.
It seems like a goldmine for future research. And now the researchers also pointed out something really interesting about the type of research that's usually done on concept maps. They talked about the difference between evaluation-focused and theory-focused research. Can you explain that distinction?
Sure. So they noticed that most of the research they looked at was evaluation-oriented. This kind of research basically just wants to know if concept maps work in a particular learning setting. But theory-oriented research takes it a step further. It tries to understand why concept maps work, like what's happening in the brain that makes them so effective.
So a lot of studies show that concept maps do work, but not as many try to figure out why they work so well.
Exactly. And the authors actually pointed to a set of hypotheses proposed by Nesbitt and Aniso back in 2013. They outlined 7 cognitive mechanisms that might explain why concept maps are so beneficial. Things like dual coding, where you're using both visual and verbal memory systems. And the idea that concept maps help distribute cognitive load, making it easier to process information. They also mentioned the spatial consolidation of concepts, the clear signaling of relationships between ideas, the use of a simpler verb-noun structure, the increased elaborative processing during construction, and the need for summarizing and being concise.
All of those sound like really plausible explanations for why concept maps could be so effective. And the researchers are suggesting we need more studies that specifically look into these different mechanisms.
Absolutely. They believe that more theory-driven research is crucial if we want to really understand what makes concept maps work and for whom, like which features are most beneficial and for what kinds of learners or tasks. This kind of research could then help us design even better concept mapping tools and teaching strategies.
That makes sense. We need to go beyond just knowing that they work to understanding why they work so well. Okay, this has been a fascinating deep dive into a really substantial body of research. To sum things up for our listeners, what would you say are the main takeaways about concept maps and knowledge maps?
Well, I think the main takeaway is pretty clear. Concept maps, especially when you're actively creating them, are a really effective tool for learning. And that's true across a wide range of subjects and educational levels. We saw that creating maps generally leads to bigger improvements than just studying them, and both are more effective than a lot of traditional methods. So if you're feeling overwhelmed by a complex topic, building a concept map could be a great way to cut through all the clutter.
And we shouldn't forget the importance of time, right? The longer you use these maps, the better.
Exactly. The more you integrate concept mapping into your learning routine, the more you'll benefit. It's not just a quick fix. It's a long-term strategy for deeper understanding.
So for our listeners who are still with us, what's something they should think about after this deep dive?
Well, going back to the researchers' call for more theory-driven work, I'd challenge everyone listening to consider this. Which of those proposed cognitive benefits of concept mapping really resonates with you? Is it the dual coding, the reduced cognitive load, or the spatial organization of ideas? And based on that, would you be more likely to start creating your own maps, or would you prefer to study pre-made ones? It's something to really think about as you consider using concept maps in your own learning.
That's a great question to consider. So if you're working on a tough project or trying to understand a complicated topic or just looking for better ways to learn, think about how concept maps could help you. You could explore some of the software out there, like CMap tools, which was mentioned in the study, or even just grab a pen and paper and start visually mapping your ideas.
Absolutely. And don't be afraid to experiment and see what works best for you. Based on this research, concept mapping has the potential to really change how you learn and remember information no matter what you're trying to learn.
I think that's a great note to end on. So until next time, keep those concept maps flowing.
And happy learning.